Today we're going to go over a review of factors and multiples. Looks like we need just a little more practice on those, especially the difference in finding greatest common factor and least common multiple. So let me get my handy dandy whiteboard here. And on our whiteboard, I'm going to kind of divide this up. Oh, that's going to require the pen. Just a second. At least I knew where I put it. That's good. So on our whiteboard, we're going to think one side is for factors and the other side is for, whoo, that's not straight at all, multiples. Okay, so factors are going to end up being relatively small numbers because these are the smaller numbers that go into making up a bigger number. So let's say 20. Okay, so for factors of 20, your numbers are never going to be bigger than 20. So you could either do this as a rainbow and do 1 and 20, 2 and 10, 3, no, 4, and 5. Now remember, when you're making a rainbow and you have 1, 2, 4, 5, there's no number left between 4 and 5 in the middle. That's when you know you're done. 4, 5, 10, 20. Either there's no number left in the middle, or any number that would be left in the middle could not be multiplied with another number to make 20. So these are our factors of 20. Another way to write this, which is nice when you're trying to conserve paper, is you could do it as a T-chart, and you could put 1 and 20. Notice 1 matches up with 20 in our rainbow. Here we've just conserved space and said 1 times 20. 2 matches up with 10, so we would do 2, 10. 4 goes with 5, so we would do 4, 5. Now what ends up happening is your numbers get bigger as you go down on the left until they either meet up like they do here, 1, 2, 4, 5. There's no number between 4 and 5 that could go here. And then they get bigger as you go up on the right. So bigger as you go down on the left, bigger as you go up on the right. And eventually you're either going to come to a point where the bottom number on the left and the bottom number on the right are sequential numbers, meaning there's nothing left in between them, like 4 and 5. Or you're going to come to a point where anything that would be between this number and this number is not a factor. Okay? So notice how none of these numbers are bigger than our original number of 20, because you can't have a number that's bigger than the original and then multiply it by something and get 20. Okay, so these are factors. So when you're looking at a greatest common factor, your number is normally going to be pretty small because factors are fairly small. That's kind of strange because it's called the greatest common factor, yet the number is likely to be relatively low, not great. Now this is least common multiple, but multiples get big and they get big in a hurry. So your least common multiple is likely going to be a great number, even though it says least. So when you're looking at multiples of 20, okay, think back to factors. We said there would never be anything bigger than 20. Here, for multiples, there's never going to be anything lower than 20. We have to start with 20 because as we list out our multiples, remember we're listing this times 1, 20 times 2, 20 times 3, 20 times 4, 20 times 5. Do you see how these get big in a hurry? So when you're asked to find the greatest common factor of two numbers, it's probably going to be a lower number. But when you're asked to find a least common multiple, it's going to probably be a greater number. Okay, so with that being said, thinking about our factors and our multiples, if I said find the greatest common factor for 6 and 18. Okay. 6 and 18. We can either do a factor rainbow or a T-chart for each and find the biggest number that they both share. I'm doing a T-chart for space. 1, 6, 2, 3. See how there's nothing between 2 and 3? So even if I tried to put another number times something, it would just end up being 1, 2, 3. Oh, well, 3 is already over here, so we're done. Those are the factors of 6. Notice how there's nothing bigger than 6. 18, 1, whoops, 18 didn't go over there. 2, 9, 3, 6. Okay, so what number do they share, or what numbers do they share? Well, they both have 2, they both have 3, they both have 6. The greatest number that they share is 6 because it's bigger than 2 or 3. Now, as a factor tree, we would factor these into 2 and 3. I'm going to go with 2 and 9 so that then I get down to 3 and 3. So the prime factorization of 6 is 2 times 3. And the prime factorization of 9 is 2 times 3 times 3. Now for greatest common factor, we group the pairs and then multiply the pairs. So this is a pair, and that just becomes one of the 2's. So that becomes 1, 2. And then these 3's group and become just 1, 3. And this guy, because he doesn't have a partner, he just goes away. We don't even get to use him. Now it's different in least common multiple, but for greatest common factor, we group the pairs and then we multiply the ones we grouped. So we grouped a 2 and we grouped a 3, and 2 times 3 is 6, and that's what we came up with over here as our greatest common factor. So either way we did it, we came up with 6. Now if I said let's find least common multiple of 6 and 18. Now remember, we just learned that for greatest common factor, likely going to be a lower number. Least common multiple, likely going to be a bigger number, which doesn't make any sense because greatest is the opposite of what you would think here, and least is the opposite of what you would think here. So again, you have choices. You can either say, well, I know my multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 8. Whoops. 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. Okay, let's see if that's enough. Down here, when I start listing my factors of 18, 18 times 1 is 18. 18 times 2 is 36. I see that right away we've got 2 matches. I see that we have 18 and 18. And we also have 36 and 36, but we're looking for the least or lowest multiple that they share, which would be 18, because that's lower than their next common multiple, 36. So this should be 18. Now let's check it the factor tree way. So remember, here we grouped our pairs and then we multiplied those pairs together. Here, the process is a little different. So again, let's factor. Okay. Now, even though the process is a little different, the factors are exactly the same. 6 is still 2 and 3. 18 is still 2 and 9, and then 3 and 3. So the factors are 2 times 3, and then 2 times 3 times 3. Now, the difference comes here. We still could group these together, and when they group together, they become 1, just like they did before. So group that, that's a 2. Group this, that's just a 3 now, because when it groups, it just becomes 1. But now we have this guy over here that just got X'd off in greatest common factor. He just was like, well, don't have a use for you. Least common multiple, he gets to count. So in least common multiple, if it has a partner, they group together and become 1, just like they did before. But least common multiple, we're like, hey, everybody counts here. So even if you don't have a partner, you get to be included. Okay, so now we have the partners that became 1, the partners that became 1, and then this guy all by himself still gets to get multiplied too. So now we're doing 2 times 3 is 6, and 6 times 3 is 18, which is what we got whenever we did our multiple list. So I'm hoping that that gives you a little more of an understanding of the difference between factors and multiples. So factors are those numbers that could be multiplied with another number to give you your original number as an answer or a product. Your least common multiple, you're making a list and you're basically going across like a multiplication chart. On a multiplication chart, when it lists the multiples of 6, it would be like 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6. That's basically what you're doing. And then you're looking for the lowest one they share. Here, group becomes 1, group becomes 1, get rid of the guy that doesn't have a buddy. But in least common multiple, a group becomes 1, a group becomes 1, and even the ones without a buddy get multiplied. So greatest common factor, you're going to end up with a lower number. Least common multiple, you'll have a higher number. Hopefully this helps you understand this a little better. The assignment that we have today has, it's a 2-page on 1. So let me see if I can share that screen with you. Just a second. Get back to screen share. Come on. Well, I had it up here a second ago. It's not wanting to let me switch. Ah, here we go. Okay. So now I'm going to show you, this is kind of what today's is going to look like. It's divided into 2 pages like this. These are notes. These are additional notes, and then I'll show you the page in just a moment. And it gives you the notes for what's a multiple over here, and the notes for what's a factor over here. You can see how the factors are the 2 numbers that can get multiplied by another number. And then here, instead of a rainbow, they just did like 1 times 20, 2 times 10, 4 times 5. If you made that T chart right through here, that would be the same. Okay. And then I'll show you on I will show you on here what today's assignment's gonna look like. 1 second. Thank you for being patient. Downloads. Desktop, that's what I want. Factors and multiple one. Ah! Okay, so now I can go back and share the screen with you. Okay, there we go. So what I wanted to show you is how you've got these big fat dots on this side and the little skinny dots on this side. And this says 1, 2, 3, 4, 5, 6. And then this one says 1, 2, 3, 4, 5, 6, but they're different. That's because this side's about multiples. This side is about factors. You're doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will show up on the portal as 12 problems because we're doing 6 and 6, even though they're not numbered 6, 7, 8, 9, 10, 11, 12. You're doing 1 through 6, 1 through 6. And so this says list 4 multiples of 4. So the first 4 multiples. So you would do 4 times 1, 4, 4 times 2, 8, 4 times 3, 12. And you would just list them as, is it gonna let me draw on here? You would just list them as 4, 8, 12, 16. Is 18 a multiple of 6? Is anywhere on your 6 multiplication chart, if you were doing 6 times 1, 6 times 2, 6 times 3, 6 times 4, would 18 ever be on that row? Yes, because 6 times 3 is 18, so yes, that's a multiple. List 3 multiples of 7s. You would do 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. Now over here, the factors of 16. So you'd want to do like a rainbow, 1 and 16, 2 and 8, 4 and 4. Is 3 a factor of 21? Could you multiply 3 with something else to get 21? Yes, because 3 times 7 would be 21. So hopefully you see kind of how this is gonna go. I hope this should be pretty simple. We have a part 2 to this for tomorrow, and then one more activity kind of like this for Thursday. So I'm going to post this on the portal, and if you have any questions with it, let me know. If you have any questions about finding factors and multiples in general, let me know. Hopefully this has been helpful, and I will see you soon. I miss you. I wish we could get back to school, but I just don't know. So let me know if you have any questions, and we'll go from there. Thanks. Bye.